Hi everyone, this is Dr. Harshdeep Joshi from Mechanical Engineering Department, Dr. Babasaheb Ambedkar Technological University, Lonere. This video is being created to cover the part of syllabus which we could not cover in the class because of the lockdown. So in the last class we were actually discussing about the robot end effectors. So the part which was remaining from this particular topic will be covered in this particular this. I hope all of you are safe and taking care of your family. Follow the do's and don'ts, protect yourself and others. Together we can fight coronavirus. Let us see what was the part which we already covered under this particular topic. If you remember, we have started our discussion with the types of end effectors. We discussed about two types of end effectors. First one was grippers. The second one is different types of tools, for example welding torch, spray painting gun, spanners, etc. We have started our discussion about the grippers. Under that, there are basically two major types of grippers. One is mechanical grippers, where the frictional force between the gripper or the fingers and the surface of the object to be held is the main principle behind this particular type of gripper. Whereas there are a few other types of gripping methodologies which we are going to cover in this particular session. Mechanical grippers we have already covered, and in today's session we'll be mainly talking about the other principles for gripping, which is mainly not based upon the friction between the fingers and the hold. Under that, the first type of gripper is vacuum, or this is also called as suction cup gripper. As you can see in this particular slide, you can see the vacuum cup here, which is attached to the end of the robotic arm. In this case, it's not actually a robot. This is a jib crane hook, but a similar type of arrangement is also available in the robots. You can see that such type of vacuum cups are attached, and these are being used for lifting a plate in this particular. This type of gripper is especially suitable for the delicate materials such as glass, windshield of the cars, where the mechanical gripping force may damage the surface of this particular object. This is suitable for the objects such as plate, where the gripping surface is not available, like we have seen just now in the example in the previous slide. Gripping force mainly depends upon the surface quality, surface area, and the magnitude of the vacuum force. As the name indicates, if the surface quality is poor, for example, if the surface roughness or the surface is rough, or there is dust and dirt on the surface, or the surface or the gripping surface area is less, then obviously it becomes very difficult to use this type of grippers. It is easy to operate. That's one of the biggest advantage of this particular type of gripper. Ejection is very easy in this case. We really don't require any type of ejection methodology for removal of the part being held. For example, if you just remove the vacuum which has been created in the suction cup, the part can be removed. But the drawback of this particular type of gripper is this is only useful for the plane surfaces. This is useful for lightweight, because if the weight is higher, and even if a small gap is available, and if the suction is not sufficient, or the vacuum is not sufficient to hold the surface, it can also cause some type of accidents. As we discussed earlier, the surface quality is very important in this case. So if the surface quality is poor, like in case of casting, obviously this type of grippers cannot be used because the surface is not plane. They're suitable for the surfaces like glass, where the surface is very plain. Or if the plates are dirty, if there is some dust particles or some other kind of impurities are there onto the surface of the plate, again this type of gripper cannot be used. As we had just now discussed, if there are some openings onto the plate, for example, there can be some oil holes, some ventilation ports into the plates. So if this type of parts are available where you are actually gripping the surface, then obviously the vacuum cannot be created. So this type of gripper will not be used in such type of applications. We need to take proper care and frequent replacement of the vacuum cups, because these are the cups which are directly coming in contact with the material. So there will be some wear and tear of these cups. So we may frequently need to replace these cups, and we have to ensure that these cups are properly cleaned and there is no damage on the surface of the cup. In the first slide, what we typically do is we have some mechanism, like here you can see that there is a air cylinder, and here there is another air cylinder, and this is actually the permanent magnet. So when you want to eject it, then we'll have to apply some force, a pneumatic force is applied, so that these plungers will come out, and then this will remove the plate from this particular paper. So that's an additional thing which we need to design and consider when we are talking about a gripper like magnetic gripper. One more biggest problem with the magnetic gripper is the residual magnetism. As we know that if ferromagnetic material comes in contact with the magnet for some time, so even though after the magnet is removed, this ferromagnetic material still have some amount of magnetism into it. So this actually becomes a problem in the industrial situation, because then it will attract the the ferromagnetic materials around it. Some chips of the part, or some small components, some small nuts and bolts around the shop floor, this will be attracted towards the part. So this becomes a difficulty. Next drawback of this type of gripper is only magnetic materials can be handled with this type of gripper. Will not be able to handle like copper, steel, I mean stainless steel, or some other type of materials, or let us say plastic parts which are not magnetic. So this type of gripper will not be useful. Sometimes the magnetic field and some other magnetic field or some other magnetic materials in between the path may also disturb the functioning of this particular type of gripper. Some of these drawbacks can be eliminated with the next principle, which is actually the adhesive gripper. Adhesive gripper, as the name indicates, typically what we have is just we have a surface on which there will be an adhesive layer, like we typically use a double-sided tape or something like that. So there will be some amount of adhesive which will be applied on this surface. So and whatever component you want to lift, so those components can be easily lifted with this help of the adhesive grippers. So obviously some of the drawbacks which we have seen it earlier, like this, in this case the material need not to be a magnetic material. Any type of material can be lifted with the help of adhesive gripper. So this is suitable for the objects like plates. Again, the same thing, where the gripper surfaces are not available, and then the magnetic grippers cannot be used in this case. This is useful for small parts like nuts, bolts, screws, etc. Obviously, this is also one of the drawback, that will not be able to use it for the large part, because if you use it for the large part, then obviously the amount of adhesive which we need to apply, or the adhesive force which is required, is large. It's very easy to design, similar to the earlier one. We only require to have a surface. There is no mechanism like in case of mechanical grippers. So its design is very easy. Its operation is also very easy, similar to all of the earlier other principal grippers. It can handle the parts with holes. This is again similar to the magnetic gripper. It can handle parts made up of a non-magnetic material. This was one of the major drawback of the magnetic gripper, which has been eliminated in case of the adhesive gripper. So we can even handle the parts like copper, aluminum, or maybe like plastic, etc. These type of parts can also be easily handled with the help of this type of gripper. The adhesive remaining on the surface of the object is one of the biggest problem. This typically makes the surface dirty. that if you remember, in the earlier two types of grippers we have mentioned that there is no mark on the surface. So that was the kind of advantage in the earlier types of grippers, whereas the same thing becomes a disadvantage in this case, because even though if we release that particular part, then also that adhesive, some part will always remain onto the surface, and then we need some cleaning or some additional process we need to do it to remove that adhesive part which is remain on the object. This can be used for the light objects, this we already discussed. uh, it's necessary that the surface has to be clean. If there is some dust or on the surface, it may reduce the adhesiveness, so obviously the functionality will not be as expected. Separate arrangements are required for the ejection, because this will be similar to the adhesive gripper which we have discussed earlier. Sorry, the magnetic grippers which we discussed earlier. In case of magnetic gripper, we had made a separate arrangement for the ejection. In this case also, obviously when you want to eject the part, we have to have some additional mechanism through which we'll be ejecting that particular part. One more additional requirement for this particular type of gripper is that adhesive needs to be replaced after a regular interval, as we typically see that after some usage the adhesive will lose its capacity to hold the parts, and then we need to replace it. Either we have to reapply the adhesive layer, or probably that complete adhesive pad we'll have to replace. So that provision we'll have to provide onto this type of gripper. One thing which was missed out earlier, there is some problem with this slide. Sorry for that. So if the adhesive power is weakened, then there are chances of accident. This is similar to the problem which we had discussed in earlier grippers as well. Next type of gripping is very interesting. This is actually an expandable bladder. Obviously this is not common to all the types of parts, but sometimes what happens is if the outer surface is already machined, and then we do not want to use that surface for the gripping, especially for mechanical grippers where the gripping marks can be there because of the pressure which is applied from the mechanical grippers, or like adhesive gripper where the adhesive marks will remain onto the surface. So in that case it becomes difficult to hold a component. For example, if this is a particular component which we want to hold, and then the outer surface we do not want to use it for holding, in that case this particular type of gripper becomes the one of the most useful type of gripper. In this case what happens is, as you can see it here, we have a balloon kind of thing. You have a top and bottom ring, and there is a port from which the air can be filled. So if we fill up air into this, it will become like a balloon. So what happens is we make use of the inner surface in this case, and what we do is we will just insert this particular type of part inside the component, and then we'll fill up it with the air. So obviously this bladder will get expanded, and then this inner surface it will grip. This bladder will be used as a gripper from the inner surface. So if we lift this particular bladder, then along with that complete component will get lifted. And the advantage of this type of system again will be, as I just now mentioned, when the outer surface is not available for gripping, inner surface you can use it for the gripping. Its design is very easy, operation is also very easy. Relieving the part or the ejection of the part is not a problem, because as soon as you release the air from this particular bladder, automatically the bladder will get contracted, and then the gripper will come out of the part, and then the part can be placed wherever you require. So these are some of the advantages of this type of gripper. In addition, more types of grippers which come under the other principles of gripping. First one is scoops. Typically these scoops are used for the material like let us say sand, or maybe some material, some powders or something like that, where it becomes difficult to use a mechanical gripper. Similarly, it becomes difficult to use a magnetic gripper or any other type of gripper like the adhesive gripper and all, because you'll not be able to eject that powder afterwards. So for this type of systems, typically a scoop will be used. Hooks are typically used whenever the part is very heavy, So obviously all these other principles of greeping will not be able to use it, and even the mechanical gripper, if the part is very big and very heavy, will not be able to hold that part into two greeping surfaces. In that case, it becomes easier to put a hook inside that, and then that hook can be held with the help of another hook onto the robot in wrist. So hooks can also be used in that case. Sometimes we can make use of the screws. We can have some threaded part onto the object to be lifted or handled, and then a screw kind of structure can be inserted into it, and then that will be attached to the end effect to the wrist of the robot, and this is how actually the gripping can be done. In addition to that, there can be many other types of grippers. There is no end to it. Multiple types of grippers can be used for holding the surfaces, and it all depends upon how and where we are going to use this particular robot, or where we are going to use these grippers. Now we'll discuss uh, the other types of end effectors, which typically are called as tools. For example, if we want to use a robot for a spot welding, so there are two options. One is to hold a stop welding gun onto the robot gripper, and the other one is directly fit the spot welding gun onto the robot wrist itself. So obviously the second option is used in most of the cases. Next one is arc welding torch. Similar to the spot welding torch or gun, we can also have an arc welding torch directly attached to the end effector. Spray painting nozzles, spray painting guns can directly be attached to the uh, wrist of the robot. We can also attach the rotating spindles, for example, drilling, that is drill, tap, grinding, well, spanners. These type of things we can directly attach to the end of the robot. In one of the other lecture, when we'll be talking about the applications, I'll try to show you small clips about applications of all these types of tools, and how these tools are directly used onto the end effector. We can also use the gluing gun. For example, if you want to paste two parts together, so this in the applications of the robot, if you remember, this was one of the interesting application which we had discussed in the very first unit. So for that, we can directly use the gluing gun onto the surface. Heating torch can also be used as the end effector or the tool onto the robot wrist directly. Laser torch can be used for, let us say, cutting the material, or maybe laser sintering or some other type of applications. Directly the torch can be used. Markers can also be used. For example, on some of the components we want to just put some marking, or some noting we want to put it onto it, so the markers can directly be used. Inspection tools like go gauge, no go gauge, or maybe some other types of gauges can also be used onto the robot wrist, so that uh, the whatever intended function is there, that can directly be done, and there is absolutely no need to hold these components onto the grippers and then do the job. Instead of that, directly we can put all these types of whatever list you are seeing here, all these types of tools, we can directly use it onto the uh, directly we can use it onto the wrist of the robot, and then that's how it is called as end effectors. Now, what are the considerations during selection of the grippers? So in that, first consideration is part to be handled. We need to understand which part we want to handle, and according to that we'll have to select the grippers. Especially the parameters which will be important from the part to be handled are, for example, weight of the part which we are going to use it. As we discussed earlier, suppose the part is very heavy, we will not be able to use the grippers like adhesive grippers, magnetic grippers, or the uh, suction cup grippers, etc. Shape of the part, if you do not get a holding surface or a gripping surface, then it becomes difficult to use the mechanical type of grippers in that case. So we have to take into account which is the shape which we are going to handle. Uh, Changes in shape during the processing. It may happen that the initial shape is, let us say, a prismatic shape, but during the processing it becomes, let us say, a cylindrical shape. So this type of changes, whether your gripper is capable of handling both this type of shapes or not, that also we need to take into account. Tolerances and on the parts or the size of the part, that we need to accommodate. For example, if we are having very large tolerances on the part, then probably we may think that our gripper has already hold the part, but it might not have reached to that particular part by that time, and then the gripping action will not take place in that case. Surface conditions, surface protection or protection of the delicate surfaces, this also will have to take into account. Surface condition means whether the part is just being painted. There can be situations like there is, or let us say, moisture layer onto the surface, or there is some chemical layer onto the surface, or there may be many other things. There may be a wax layer onto the surface. So, what is the surface condition? There can be some dust particles. Sometimes there can be dust. Suppose if you are handling casting, then there can be some sand particles onto the surface. So all these things we need to take into account while considering the selection of the gripper for handling the part. Next type of principle is principle of gripping. Which type of principle will be suitable for using the for using the gripper, that we have to take into account. For example, whether the mechanical principle is suitable or whether vacuum is suitable, whether magnetism is useful. For example, if the material is not magnetic, obviously we will not be able to use a magnetic gripper in that case. So that also we need to before selection of the gripper. We have to talk. We have to also think about what is the power source which we are going to use it for the gripping action. Whether it is a mechanical force which you are going to use, or whether it is a pneumatic force which you are going to use. With the hydraulic force we are going to use it, or the electrical power we are going to use it as the power source for the grippers. We already discussed about which particular type of power source is suitable when we are talking about the drive selection for the robots. So the relative advantages, limitations, and where we can use which particular type of gripper, those discussions we have already completed in the one of the previous units. So we'll not repeat that part here again. Next consideration is the gripping force. This typically depends upon the weight of the object. If the object is heavy, so obviously you require higher gripping force. And if the surfaces are delicate, if we are not able to give that much gripping force to it, so obviously the gripper hooks will be more suitable in that particular application. Method of holding. What are the constraints? There can be some surfaces which are actually good for holding. However, these surfaces may be constrained. These surfaces may not be used for gripping because of one or the other reason. Like that may be the external surface, and then that surface may not be used for gripping because there can be some gripping marks. There can be some damage to the surface, so that cannot be used sometimes. Or sometimes the frictional force may not be sufficient onto some of the surfaces. So these things we need to take into account. Coefficient of friction between the fingers and the objects, that we need to do it. We have already used it in the calculations, if you remember, in the previous class when we are doing it into the classroom. So that we'll have to take into account while selecting the gripper. Speed and acceleration during the motion. Sometimes it may happen that if the object is being moved from one place to other place with a very high speed or very high acceleration, so there are chances that your gripping force which you have calculated, we have taken only the static conditions during those calculations in the class. So it may happen that those forces may not be sufficient, and then probably the object may get slipped while transporting it from another place. Next type of consideration is positioning problems. Like length of the fingers. Sometimes if the length of the fingers of your gripper are very large, probably it may obstacle some other objects into the path, and then that may damage some other parts, or it may not be possible to use those types of fingers in the given application. Inherent accuracy and reliability of the robot, how much accurately you can position to that particular part, that also becomes important. For selection of the gripper, if your accuracy is poor, probably mechanical grippers may not be suitable in that particular case. You may miss the location. Tolerance on the size and part. size of the parts that we. Next one is service condition. Service condition basically means in which particular situation we are going to use our gripper. In that, the first consideration is number of operations during the lifetime. How many times we are going to use this particular gripper in its lifetime, for example, or in other sense we also call it as a duty cycle. How many times we are going to use it in a day, in a week, in a month, in a year, or something like that. So for example, if you're using a adhesive gripper and then if the duty cycle is large, the amount of the number of times we are going to use it in a day is, let us say, very large. So obviously we'll have to replace its adhesive surface very frequently. So under such situations, probably that type of gripper may not be that suitable. Wear and tear of the contact surfaces, especially in case of mechanical gripper, the parts are being held with the help of friction. So because of the friction, there is going to be some wear and tear on the parts on the gripper surfaces. So we need to take it into account, and then those provisions have to be there. Or let us say we have already discussed in case of vacuum cup, typically a rubber cup is used. Rubber surfaces are used near the gripping, so there are chances that these surfaces may get damaged very quickly. Next one is replacement of the part, as we have discussed earlier in case of adhesive grippers. So adhesive surfaces needs to be replaced. Friction surfaces in case of mechanical grippers, or maybe the rubber cups in case of suction cup type of gripper or vacuum cup type of grippers needs to be replaced. So we have to make the provisions so that these parts can be easily replaced. We need not to call a mechanic for doing this type of replacements, or may not be, we may not call the company guys always for doing this type of small replacements in the gripper. Otherwise the cost goes high. So serviceability and maintainability, we have to ensure that if some of the part goes wrong in case of the gripper, there has to be some method, some provision by which we will be able to service it or maintain the gripper. Otherwise it becomes difficult, or we'll have to throw away the gripper completely, and then we'll have to use other gripper which actually will increase the cost of the system as such, or cost of the robot. Operating conditions, once again, there can be the situations like heat. If we are using the gripper very close to the furnace or somewhere, then obviously there is going to be very high heat, so the rubber parts onto the grippers may get damaged. Temperatures can be very high, humidity can be there, so this humidity or the moisture can sometimes reduce the friction between the holding surfaces. These dirt particles probably may damage the gripper surfaces, or sometimes it becomes difficult to hold the surfaces. Suppose you are using a adhesive gripper, then this dirt particles may affect the performance of this type of grippers. Sometimes if you are holding or handling some particular chemicals, then these may also affect the performance of going to use it. Other miscellaneous considerations which are there during the selection are like interchangeable parts or fingers. Many times we see that if you are using a particular robot, then we may need to replace only the end effector or only the gripper for handling different types of parts, whereas the robot will remain the same. Or sometimes what will happen is only the fingers which we are going to use are going to be changed depending upon the parts which we are going to handle in different situations. Design standards also will have to take into account. We have to ensure that all standards are followed while designing the particular gripper, because it is connected with the safety of the operators or the safety of the work environment. Mounting connections and interfacing with the robot. The connections should be possible. For example, if you are using a tool directly, if you are using, let us say, the go no go gauge, then what is the outcome of your measurement? Or if you are using, let us say, some other measurement device there, so what is the outcome of that? That should be possible, that should be connected with the robot. Universal nature of the gripper, here we basically talk about multi-purpose applications of the robot. That will depend upon how the grippers are. For example, if you are using a robot for gripping a particular type of atom, tomorrow if you want to use the same gripper for some other application within the shop floor, if the grippers are not interchangeable, then probably it will become difficult to use that robot in that particular application. Changes in the product design and its effect on the gripper design. So there are continuously changes taking place in the product design in the industry. So we cannot change the tooling or the machinery or the equipment for small changes into the product. So your gripper has to take into account that those small changes which may happen into the product design, it should be able to accommodate. Lead time for design and fabrication has to be small as possible. Spare parts should be easily available. Maintenance should be possible. Serviceability should be possible. This all we already discussed in one of the parts. It should be able to accommodate the variations of size in raw material. This also we have discussed earlier about the tolerances. Otherwise, it may become useless, or some of the raw material will not be used. It may be rejected in the application. It should be able to accommodate the variation in size during the operation. We have already discussed, suppose initial part is very large, but during the operation it may get cut into smaller pieces. So the gripper should be capable of handling large part as well as the small pieces as such. Protection of the gripping surfaces, it must not distort too much. Typically, as we have discussed earlier, in case of mechanical grippers, always what we do is we always use softer material on the grippers, because this is the part which can be replaced after the use. However, if the gripper surfaces are very hard and if they damage the surface of the finished part, then the loss will be more. So obviously we expect that the grippers should be softer, but it should not be too soft that it will distort too much and there will be some scratch marks on the gripping, or the gripping marks on the components. It should not damage the paints, coatings on the components. That has to be taken care of. And the last consideration in this case will be economics. Economics, especially in case of the industrial equipment, is looked at in two different ways. We typically call it as the initial cost or the initial investment. We typically talk about return on investment from this particular perspective. Whenever we buy equipment, we always see that what is going to be the initial cost of the equipment and how much time it will take to recover the cost of buying that new equipment. That we typically talk about the initial cost. But many a times it happens that the initial cost of some equipment is very less, but the recurring cost, the maintenance cost, or some of the consumable cost which will be required is high. So that also eventually results into loss to the organization. So we have to also talk about what is the cost of maintenance, what is the frequency of maintenance required, what is the cost of maintenance every time, and in a sense we have to talk about total life cycle cost. That means we have to consider the total cost which you are which is involved into that equipment during its total life cycle, and based upon that we'll have to select the equipment. Similar is the case in case of grippers as well. So this is all about the grippers. So we'll stop here for today. In the next, as I mentioned earlier, the topics which we could not cover it in the class, we'll try to cover it through this type of web sessions. So the is going to be on robot programming, which is our unit number 5. So this will be divided into parts. So the first part is going to be lead through programming methods, which I'll be streaming very soon. So thank you all of you for patience listening, and I request all of you to subscribe to my channel so that you will get the updates about the newer videos on further topics related to this subject. I also request you to give the feedback in the comments for this particular presentation so that we can improve based upon that in coming days. Thank you all.